They're not very hard to understand, are they?
They're not that hard.
No, not at all. They're fun.
Yeah. I think it was just going to be easier when we stop hard coding them out and just like start implementing the already made methods there.
Yeah, there is already made ones, and that's your own baby, but we never implement what we do not understand. That was one of my first sponsors, big rules, and that served me very well and for many years, that if you do not fundamentally and clearly understand what that built-in stuff does, no touch. Okay. So let's just go through this. And remember, there's built-in stuff, but there's nothing built-in for a circular linked list. Okay, and there's also, next we're doing pointers and then stacks and queues and priority queues, and then trees and graphs, there's nothing built in for that. Okay, that you have to code up from the beginning, from scratch. So it is nice to grow with linked lists to the point where a tree seems easy, or otherwise, if you did the built-in stuff and you hit a tree, if you had to start working with nodes that points to two different directions, in different hierarchical levels, it would get ugly. So, yeah. Let's have a little look at circular linked lists. So we know that circular linked lists just point back to each other. So the trick is when you make the head node actually points back to itself. You guys see that? So when you make a head, if the head is null, when you want to append, we create a new node, we set that node to head, and we make its next value itself. Then we go and we set current to head. Okay, and we use current just to iterate over these guys. And current is currently pointing at itself.
Serena,
so it's, yeah.
you're not screen sharing.
Oh, you guys must tell me this before I look like a moron for like an hour. Sorry about that. Now I have to go all the way back to the beginning. Can you see my stuff now?
Yes, we can.
Can you?
Yeah, we can.
Okay. Are you guys broken? Do we ever have 4 hours again like this? Because it can't happen. We have to make a plan. We'll move stuff ourselves. Okay. So, in the append method for a circular linked list, the first thing we'd go and do and we check if there is a head. Okay. If there isn't a head, we make a custom node and we call it a head, the empty head, and we actually set its next pointer to point to itself. Okay. So can you guys see that in the code? Does it make clear sense?
Yes.
Yeah.
Thank you. Okay. I'm going to start playing elevator music when you don't answer me. Okay. So if we have a head, now if we are appending and we're not starting with an empty list, we set that head to current. And then if I check if current.next doesn't equal the head. Okay, do you guys see that? Where in the past we used to say, well, current.next does not equal null. It is now does not equals head. Then we can say current equals current.next. Okay, but current.next here does equal the head. Do you guys agree? So we exit the loop, we make a new node, and we move on. So now when we have head is current, and we've got a new node, and next points to that node, the next value then is not head on the second iteration of that loop. Do you guys see this? Okay. So the new node is the next value, okay? And the new node's next value is head. Do you guys see this? That we set the new node's next value to head. So the new node, the end nodes we append here, their next value is always head. So that as we start adding to this list, every new node we make, we set its next value to head. So that we are always linked to the head. So that is really the only difference between a singular linked list and a singular, somebody help me, a singly circular linked list is this little extra step at the end. The loop is a bit different, but we just always make sure that current.next is not the head. Okay. So, and then so that we can walk through the list. And we always set the last node we make to link up with the head node. Okay, and this is a singly linked list. If we want a doubly circular linked list, we also do it the other way around. And that will be the last thing we do for lists. Does singly circular linked lists make sense to you guys?
Yeah, they do.
Yeah.
The theory actually makes a lot of sense.
In theory, it does. It's the code that breaks it, but the code makes crystal clear sense. Look here at the code.
Yes. Yes.
Is head, okay? While current.next does not equals head. Current.next yet doesn't equals head. Current.next is this node. Then it says, okay, then current.next.next. So does this node's next pointer equals head? Does it?
No, it doesn't.
No, it doesn't. But the current.next.next is also empty. So then we can say, okay, make a new node for us. Boom. Do you see this? And
yeah, I get it.
And set that new node's next pointer back to head. And then we have a circular linked list. So the code should make crystal clear sense.
Yes, it does.
Okay, you should be able to read the code like a story. Okay.
Yes.
Right. That is it for me for today. I am fairly shattered. How are you guys feeling?
Mental health, not so great.
Mental health, not so great. Is it the research that did it or the combination of research and pride?
It's a combination. Definitely the combination.
Agreed.
Agreed. Okay, I'm sorry for your shattered brains. So now go and relax for an hour before you look at anything else before you break it. And I'll see you guys again next week. And I think you have to finish up your apps because next week we're going to start adding cues and stacks. No, actually I'm lying. Next week is pointers. We're going to go through pointers. That's really quick. And then we'll start implementing cues and stacks.
All right. Thank you.
Okay. Okay, guys. Have a nice day.
Thank you. See you, Serena. Bye.
Bye.
Thank you.